When you put this arrow, you're saying to the reader that the numbers actually get what? Larger and larger. So that arrow means it goes on forever. So the number like 1,000.6 is on the list, 1,000,000,000 is on the list, 1,000,000,000,000 is on the list, 1,000,000,000,000 is on the list, because we're putting this arrow shaded where? To the right. Okay, you guys okay with that? So what you're looking at is a picture of the graph of numbers that are what? Greater than 5. Okay, so all of this kind of goes together. So the phrase is going to be graph these numbers. This is the description. Below is your what? Is your graph. And this is where we're going to start. Okay, we're going to start about this process. Does anybody have any questions on what you're just looking at right now? You sure? Is that easy or hard? Okay, well can you guys have this in your notes here? All right, let's get rid of this. Let's actually show you other sort of examples, because that's where we have to start here, is with the examples, the notation. Once we get that notation and all these different settings out of the way, we can now do more meaningful type of problems. So when you go to Math 125, Intermediate Algebra, they're going to want you to work with various notation. And this is where you start. Okay? This is first called the graph. This is a description. We'll talk about set notation. We'll talk about interval notation. We'll talk about all those notations, and then we'll solve some linear inequalities. So let's work on some of these questions. For example, they're going to say to you, all of these are going to be graphing questions. Graph numbers that are smaller than, let's say, 3. Okay, so you're going to start by drawing the real number line again. And in the middle, what are we going to put? We're going to put that neutral location of 0. Now you may say, why do I put the 0? Well, I want to locate where the reference number is. Where's this reference number at? Positive 3 lives where? To the right of 0 or to the left? So here's where 3 may live. Is that true? Put a open circle around the 3. And I erase the phrase, but it's in your notes. What kind of numbers are we describing? Numbers what? Less than 3. This is your less than symbol. Numbers that are less than are what? What do you guys think? Numbers less than? What kind of numbers? What kind of numbers are we talking about? Less than. Those are numbers that are what? Smaller than. Good. What numbers are smaller than 3? Numbers that live where? To the right of 3 or to the left of 3? Left. So you're going to shade the portion of the real number line, okay, that is to the left of 3. Make sure you put your arrow indicating that the list of numbers goes on what? Forever to the left. So you guys are looking at the graph here of numbers less than 3. Okay, you okay with this? All right, let's continue. What if I said, can you describe numbers that are greater than or equal to 12? This is now greater than or equal. So you start with your 0, right in the middle. Now, where's the reference number at? Where's 12 on the real number line? Is it to the right of 0 or to the left of 0? Okay, so I locate where 12 could be. I'm going to put my circle here. And now what I want to consider is, what kind of symbol is this? What symbol is this? You guys remember? That's greater than or what? Equal. So let's describe numbers that are greater than 12. Numbers greater than 12 live in what direction? To the right of 12 or to the left? Okay, so shade numbers where? To that right. Is everybody okay with that portion? We're describing numbers that are larger than 12. Numbers larger than 12 live to the right. All of these numbers to the right of 12, like 13, 14, 15, 25, a million, are numbers that are greater than 12. But this isn't the symbol we have. We have the greater than or what? Or equal. So what do you think, how do we have to communicate to readers that we actually use the the concept that we can also equal 12. Or the possibility. What do? Good, you shade your circle for 12. You guys remember this high school notation, right? You got the shaded dot because we include the 12. You got the non-shaded dot because we do not include the 5 over here. Okay, so this is kind of what you'll see. Less than, greater than, or equal to. This was greater than. Okay, what is missing? What do we have to talk about now? What do you guys think? What's the next example coming your way? Can you guys put that together? Less than or equal to, right? So let's look at some examples here. Oops, less than or equal to. Okay, so this is a graph scenario again where I have to graph numbers, let's say, that are less than or equal to -5. Okay, so the first step again is to draw that real number line for you. I locate where 0 would be. Where would -5 be? To the right or to the left? To the left? Okay. Maybe over here somewhere -5. Okay, now go back and read what this means. This means what? What kind of symbol is that? Less than or what? Are equal. How do you know it includes the possibility of equaling -5? That line there. Okay, so when you put your circle now around that location of where -5 would be, make sure you do what? You shade it because it includes the possibility of being -5. And then when you shade, what numbers are less than the -5? Or what numbers are they really talking about? Numbers that are what? Smaller or larger? Smaller. Where are they at? To the left. So what are you going to do? Shade all the numbers to the left. So I'm going to shade this way. Those are numbers to the left. I'm going to put my arrow, and that's kind of communicating to the reader that what? These numbers go on what? Forever to the left. So here's the graph of numbers that are less than or equal to what? -5. Okay, you guys okay with this? Now notice, what did I call this earlier? This was my what? This phrase you guys are looking at, I said was my description. Is that true? So this here is also the what? Description. So I'm describing by writing down that phrase. This is a description here of the numbers. Okay? Everybody okay with that? Now, we're looking at these things called the graphs. So let me write over here. We have the graph. We also have something that we call set notation. Does anybody know what a set is in mathematics? What's a set? Good. A set is a what? Is a list. So we actually, when we list things in math, we actually call that, we created a set. We have a set. So you guys have made lists in your life. What kind of lists have you guys made? Grocery list? Right, what kind of things you get on the, put on your grocery list? Anybody know? What do you put on? You guys have worked this before. What do you put on your grocery list? Ice cream? No? Doritos? Right? Potato chips, ice cream, what else? Huh? Chorizo? Frozen pizza? Is that on your grocery list? Probably, right? That's your grocery list. What other kind of lists have you made? Anybody ever make a Christmas list? Who's on your Christmas list? Christmas is coming. Who's on the list? You put Santa on the list? So who's usually on your list? Mom, what? Dad? brother, sister, Mr. Judge. He's on the Christmas list, right? Okay, so you guys have made lists before. What we're talking about in mathematics is a set. Remember those numbers we try to list that are greater than 5? Okay, we were actually writing down in some ways a set. This is a picture of the set called the graph. But we want to write down formal set notation. Set notation, ladies and gentlemen, looks like this. Let me put, for example, over here, let's move this problem, x greater than 5. Let's do that first. Here's where 0 would be. Here's where 5. We have an open circle. Shade everything to the right. Okay, now I'm going to erase what we have here. And I'm going to describe to you guys what kind of notation we use. We want to use set notation. Here's what we use. We use what we call curly brackets. So if you've ever seen curly brackets in your life, that's set notation. We use this for set notation. So like I said, if we put on our grocery list, what's on your grocery list again? Ice cream? Doritos? How do you spell Doritos? Is that how you spell Doritos? I don't order Doritos. What else you put? All right, we put a what? You put Doritos. What else? Is that how you spell Doritos? Or is it 2 R's, 2 T's? I have no idea. Ice cream. I can spell ice cream. What else? Bread. Soda. Milk? Okay. And when we close the list, we put the other curly bracket. Okay? This is a set. But the kind of sets we work with in algebra look like this. It's a set with this x and a line, and we close this. You see, we can write everything on the list this way. This is our grocery list. We can write it down this way. But as you guys seen, if I listed my numbers, I would die before I actually finished the list. Okay? So I can't actually do this process the same way with set notation. So here's what we do in math. We kind of cheat a little. You say, well, what are you talking about? Well, when you see the brackets, that means what? The set. And what comes next? X. So as you guys read left to right, here's what you guys want to see. This is the set of all, we use that, the set of all real numbers that we represented with what? The letter X. You see this this vertical line? You know what that means? That's the phrase such that. So when we read this, it's the set of all x, or the set of all real numbers, such that what comes next here is your what? Description of those numbers. Okay, so here that we wrote down, this is my description again. This thing is called the graph. If you had to write set notation, and sometimes they want you to do that, you would put the set of all x. Set x. This line means such that. Let's close this thing. What do we say this was? This was the description. Is that true? So what am I going to put here? X greater than what? 5. You guys are looking at what we call set notation. Graph. This is the graph. This is what? Set notation. So sometimes they ask you to write the set notation. Okay, you guys with me on this? Is that easy or is that hard? It's about learning how to describe things. What about the set notation here? How would I use my set notation for this problem? Isn't this a set of all x such that what? What's my description here? What does it say? This is x what? Less than or equal to negative 5?